Hi, what's up, guys? We are back with a brand new one. We are going to be looking at the simplification of algebraic fractions using factorization today. So, we're going to start off with a basic fraction, okay? And we're going to make use of everything we've learned up until this point, okay? So, we know when it comes to factorization, we want to find what we call the highest common factor, right? And if we look at the numerator, what would our highest common factor be, right? So the biggest number there would be 3. We know 3 can go into itself once and into 6 twice, right? So we're going to take out a common factor of 3, a highest common factor of 3, okay? So let's complete the sum. So if we take out a highest common factor of 3, what are we left with? We're left with x plus 2, right? Over 3. So remember, the denominator is still in place, okay? So as we can see now, that 3 goes into itself once, so it cancels, okay? What am I left with? I'm left with x plus 2. Okay, and that's my answer. Quite simple, eh? Not difficult. Okay, so that's a warm-up question. So let's go and check out another one, okay? So let's take it a step up. So x squared plus 2x over x, okay? So what am I going to do here? If I look again at my numerator, I see I have a HCF of x, right? Remember, in the previous videos I told you, always take the smallest exponent when looking at the variable, right? So if we look at the variable, the smallest exponent would be 1, right? So we're going to take out x to the 1. So we're going to say equals to, we take out our x, we're left with the x plus 2, right? Because we know that x times x is x squared and x times 2 is 2x, right? You guys are following? Over, remember we still have an x, right? So this cancels. X goes into x once, cancels. Again, I'm left with x plus 2. Okay, and I feel that was fairly simple, right? That shouldn't have been difficult. Okay, let's have a look at another one. Okay, let's take it a little bit up. So we're going to say 4x squared plus 4x over 2x. Okay, and looking again at the numerator, I have a HCF over there of 4x, right? Because when I look at my coefficient, I know 4 can go into itself once, and if I look at my variables, x to the 1 is again the smallest variable, right? So I know I have a highest common factor of 4x, right? So let's get into this one again. So I can take out a 4x and I'll be left with x plus 1, right? Over 2x. Now I know x goes into itself once, 2 goes into 4 twice. What am I left with? X plus 1. Okay? And that would be my answer. You guys follow? So that is all that is to that one. Okay? So remember, again, I'm going to show you 2 went into 4 2 times, x went into x once, and so it cancelled. Okay? So that's why we left with 2 times x plus 1. Right? Let's have a look at another one. Okay, I feel like you guys are getting the hang of it now. So let's take it a bit a step up. Let's put in some negatives, right? Let's do some negatives. So let's say 10a squared minus 15a over 10a. Okay, again, looking at the numerator, we're going to put that 1 there. Again, we know the smallest one when it comes to the variables is 1. So if I look at my HCF, I can see my HCF would be, biggest number that can go into both would be 5a, right? So we're going to take out a 5a, and what am I left with? If I take out a 5a, I'm left with a 2a minus 3. Okay, a 2a minus 3 over 10a. Okay, so we can quite clearly see there that 5a times 2a is 10a squared, and 5a times minus 3 will give you 15a. Okay, so we successfully got this far. Now we can see that we're sitting with a fraction that looks like this. Okay, so forget the a's. We're sitting with a fraction that looks like this. You guys with me? So what would you do in this case? You know you're going to say HCF. Okay, divide both by 5, right? So that's what we're going to do here. Okay, because we know x will go in, a will go into a once, so it cancels, right? So we can basically say we have an HCF here of 5. Okay, we can say we have an HCF here of 5. So 5 goes into itself once. Okay, 5 goes into 10 twice. What are you still left with? A 2a minus 3. Okay, you guys see that? You don't even have to write the 1. You can also write it as 2a minus 3 over 2. Okay, this is the same thing. Okay guys, let's take it another step up. Okay, let's take it another step. So let's put a little bit more variables into the equation. Okay, so if we were to say 2x, okay, let's do this one. So let's say 2xh squared, okay, minus 4x squared h over hx. Okay, again, looking at the numerator, I can see that my HCF would be 2 when it comes to the coefficients. Okay, it would be 2. And when we look at our x's, we know x to the 1 is the smaller one. And when it comes to the h's, h to the 1 is the smaller one. Okay, so it would be 2x1 h1. So 2xh. Okay, so we have a HCF of 2xh. Okay, so we say 2xh, open bracket. So we know 2xh times h will give me a 2xh squared, okay, minus 2x, okay, right, because we know 2xh times minus 2x will give me a minus 4x squared h, okay. I'm sure you guys can see that over, let's put this in the same color, over xh. Okay, so again we can see xh is can also be written as, sorry, hx can also be written as xh, because remember there is a multiplication sign in between the two, so they can interchange. 1 times 2 and 2 times 1 is exactly the same thing, right? So that means h times x is the same like x times h, right? So we can mix it up. So we can basically say that these two can cancel, and now we are left with 2h minus 2x, okay, as an answer. Alright, that wasn't too difficult. Okay, let's have a look at another one. Okay, I think it's getting exciting now. So let's have a look at this one. So we have k squared minus 4 over k squared minus 2k. Okay, and I hope you guys see what is familiar on the numerator, right? We have two perfect squares, right? So k and 4 we know are perfect squares, right? So what we're looking at here is a difference of two squares, right? Difference of two squares. So we're going to say k minus 2, k plus 2, right? You guys with me? And on the bottom, again, we can see that we can take out a common factor of k, right? So if we look at the denominator, there is an HCF of k. So if I take out the k, I'm left with k minus 2, okay? Because k times k will give you k squared, and k times minus 2 will give you minus 2k. So as we can see now that this and that can cancel, so I'm left with k plus 2 over k. Okay, and I hope we all are satisfied with today's video. Until next time, guys.